and amend your rules a little bit. So significant figures in calculation, we can only be as accurate as our least precise measure. Our least precise measure. We need to round to make it consistent with the measurements. So in short, Sig Figs provide us rules for rounding. And even if you don't get the exact same answer as an answer key, as long as you're close, you've done it right. Because there's going to be lots of steps in some of these things. So if you remember, you have to figure out how many significant digits you should have, your lowest amount of precision. And they're different between adding and subtracting and multiplying and dividing. Once you know the number of significant figures, you're going to go to that place and you're going to look to see what's immediately to the left. Just like in normal rounding, if it's less than 5, you're simply going to drop the value. It didn't have enough to make it over the hill to make it to the next number. If it's greater than 5, you're going to increase it by 1 because we assume that it's closer to the next whole number than it is to the previous whole number. Take a moment and round these measurements off to the digit in the end. That second question, I will fix. Never mind. All right, so we want 4 digits. We're going to look at the 4. We're going to look at what comes after. So when we're rounding, it's going to be 3, 1, 4.7. And we don't want any naked numbers, so we're going to carry over our unit, which is meters. Because the 2 is smaller than 5, we're going to keep that 7 the same. For the next one here, 2 significant digits. This one might be a little bit tricky because remember, these are leading zeros. If we wrote this in scientific notation, they'd go away. So those are not going to be significant. So we have 1, 2. So this is going to be our second significant digit. After that comes a 7. So this one we have to round up. So we're going to keep our placeholders 0.001, and then we're going to round that 7 to an 8 because the second 7 is greater than 5. So no naked numbers here. We got to keep our meters. And then finally, we want 2 significant digits. These are all significant right now, but because we're rounding to our least accurate, we can only keep 2 significant digits. So we're looking at the 7 and the 9. 9 is greater than 5, so we have to round up. So it's going to be 8, 0, 0, with no decimal point, otherwise those zeros would be significant. And we have to add our unit, which is meters. Hopefully you guys got that as well. For addition and subtraction, our least accurate device is the one with the least number of decimal places. So if you line up by the decimal places here, our subtraction example, you do the math as you normally would, but then we have to round. We have 2 decimal places here and 3 decimal places. 2 decimal places is our least number of decimal places for this addition and subtraction. So we have to round to 2 decimal places. There's a 6 on the other side, so we round that 8 up 1. All right, take a minute and answer A and B on that question that asks you about them. We'll go over them together in just about a second. So if you need a little bit more time, pause the video now. All right. So in order to find out our number of sig figs, we line them up, or you can just look at them and count the decimals. Our least number of decimals is 1. So even though we have 2 decimals in our answer because of our other measurements, we have to round to 1 decimal place, which gives us 369.8 meters. In that second example there, we have 8 kilograms minus 1.789 kilograms, which gives us 6.211 kilograms, but that 8 only has 1 decimal place, so we have to round to that second decimal place, sorry. We have 1, so 6.2 would be our final answer in the correct number of sig figs. All right, on your guided notes, we're going to come back to those multiplication answers. We're going to do the same thing. So in multiplication and division, it's a little different. Instead of the least number of decimals, we're going to do the least number of sig figs. So if you measured something at exactly a meter, that's why it's important that you define the precision of your measurement based on your tools. So the least number of significant figures. We don't care about the decimal when we're looking at multiplication and division, except to determine our significant figures. So in this example at the bottom, 7.54 has 3 significant figures. Actually, I think I have that. But 0.34 has 2 significant figures. So we're going to put it in our calculator and multiply to get our meters squared, but then we have to round to our least number of significant figures for multiplication and division. So we're going to get 2.6. That's 2.6 because we had to round up that 5 since there's a number greater than 5 after it. Take a minute and fill out C and D on that second to last question on your notes. All right, pause if you need more time. For our first question, we had 2.10 meters times 0.70 meters. The second measurement has 2, so we can only have 2 significant figures in our answer. So you multiply as normal, and then we round to only 2 significant figures. For our division example, it's the same thing. We get our answer. We look at our number of significant figures. That first number has 5. Our second number has 2. 2 is our least accurate in terms of significant figures. So we divide as normal, and then we round to 2 significant figures. Our rules: all non-zero numbers are significant. All zeros trapped between 2 significant figures are significant. All zeros at the end of a number and to the right of a decimal place are significant. Our leftmost zeros are not significant. They are just placeholders. The most confusing rule here, zeros at the end and to the left of an understood decimal point, so that means we don't actually see the decimal point, are not significant. So you got to be careful with zeros at the beginning and zeros at the end. That's where the decimal point matters. There are some cases in measurements can have unlimited significant figures, like counting or conversion factors. Adding and subtracting, you round to the lowest decimal. Multiplying and dividing, you round to the lowest significant digit in your work. You're ready to move on to your practice choice. If you have questions, please make sure you ask